Okay, so I have to start out with applications of logarithmic and exponential equations because I didn't finish that off yesterday. But then I'll be moving on to linear systems with 2 variables and 3 variables after that. And the reason I didn't finish it yesterday is because that knowledge was missing. Okay, so first problem states we have $10,000 to invest for 44 months. How much money will we have if we put the money into an account that has an annual interest rate of 5.5% and the interest is compounded? And there are 3 different circumstances: quarterly, monthly, and continuously. Okay, so for quarterly, the general formula that we will use is this one. And I will write it out a few times because it continuously escapes my memory, and therefore I need to reinforce it. This one. P is the principal. R is the rate of interest or the compounding factor, whatever it is. M is how many times per year it comes into effect. T is the number of years, and M is, again, the number of times per year it comes into effect. So in this case, P would be 10,000. R would be 0.055. It's quarterly, and therefore M would be 4. T is the number of years, however many years fit into 44 months. Well, that would be 3 years and 8 months, which is 3 2/3. Whereas a rational 11/3. So putting it into the calculation, A would be 10,000 times 1 plus 0.055 over 4, all to the power of 11/3 times 4, which is 44/3. Okay. So I do 1 plus and I get the answer of $12,217.60. Then, if it's monthly, it should result in more than that, right? More in the account. And so I will write out the formula again to reinforce it in my mind. the account has the principal plus 1, the principal multiplied by, and what's the multiplying factor? 1 plus the rate of interest over how many times per year it's actually updated, then all to the power of the number of years times by how many times per year it happens. Okay. So that would be 10,000, open brackets, 1 plus 0.055 over, this would be 12 times in a year, wouldn't it, if it's monthly? And then to the power of what? Well, the same thing from before. So that's 3 2/3, which is 11 over 3. And then 11 over 3 is being multiplied by 12. So I guess 132 over 3. And I end up with a higher figure, which is correct. $12,228.77. The next case is continuously. And the formula here is this. Just PERT. The principal times e to the RT. And so here, $12,234.40. And everything must be checked. Okay, that's correct. That's correct. That's correct. Excellent. Next, we are starting with $5,000 and we're going to put it into an account that earns an annual interest rate of 12%. How long should we leave the money in the account in order to double our money if interest is compounded quarterly, monthly, and continuously? Those being the 3 scenarios. Okay, so round 2. And again, I will write out the formula over and over and over again until it sticks. So the account has in it the principal multiplied by 1 plus the rate of interest over how many times it's updated per month, all to the power of how many years it is times how many updates per month. 1 plus r over m to the tm. 1 plus r over m to the tm. Okay. So their goal is to double the amount of money in the account. And therefore, if they begin with 5,000, then 10,000 is the goal. So 5,000 there, 1 plus 0.12 over 4, all to the power of 40. That's what it will be. All right, so this turns into, let's see. No, 2 equals 1.03 to the 40. So log base 1.03 of 2 equals 40. So t equals log base 1.03 of 2 over 4. And there I get how long it should be. Now, I don't have a custom log button on my calculator, believe it or not, even though it can do like literally everything. It's crazy that such a calculator exists. Anyway, so I have to do a change of base formula. So first, I'm just going to type in log 2 over log 1.03. And then divide that by 4. And I get 5.862. Apparently. I write out the formula again. A, the account holds the principal times 1 plus the rate of interest over how many updates per year to the power of how many years times however many updates per year. And 10,000 would be the goal. 5,000 is the principal. 1 plus what? 12% over 12 to the power of 12t. And so, very similar calculation, t equals 1.01 to the 12t. And how we calculate. So here we get 5.805 years. And we would expect it to be shorter, right? Next, continue the case of continuously. So what's the equation, or what's the formula rather? A equals the principal times e to the rate of interest times by how many years? Okay. So 10,000 is the goal. 5,000 is the principal. E is just E. The rate of interest is 0.12. The amount of time is the thing that we don't know. So 2 equals e to the 0.12t. So ln t over 0.12. That's what t is. And the answer is 5.776 years. So we have to check this. I really want this stuff to be done quick because I really want to move on to calculus 1. Okay, we're in agreement, and we're in agreement about that. That's good. A population of bacteria initially has 250 present, and in 5 days there will be 1,600 bacteria present. Determine the exponential growth equation for this population. Okay, what is that formula? E to the RT, right? Oh, no, e to the KT. That's the preferred variable, right? So that's the formula. And in this case, Q is 1,600. Q0 is 250. K is what we don't know. And T is 5 days from now. So solving 1,600 there, 250 there, E right there, and 5T right there. So 1,600 divided by 250 is 160 divided by 25, which is 6.4. So that's T. Ln of 6.4 over 5. No, rather, that is K. So I believe that it would be Just like that. And as for the second problem, how long will it take for the population to grow from its initial population of 250 to a population of 2,000? So what I do is I use what I've just found out in part 1, and I set 2,000 to be the goal, 250 to be the initial state, E is just E, and here 0.3713 T. And we solve for it. So 2,000 divided by 250 is 8. So ln 8 over 0.3713. But hold on just a minute. We can do better because we have it in exact form up there, don't we? So ln 6.4 over 5. Just there like that. Now hold on a minute. Ln 8 is being divided by this fraction here. Well, that's the same thing as ln 8 times 5 over ln 6.4. So 5 ln 8 over ln 6.4. And this 5 can be put up there. So we would have 2 to the 15, which is 32,768, which is cool. But anyway. So the answer is 5.601 days. And we check. Everything must be checked. That's correct. All right, I guess they want it in quote-unquote exact form. That's fine. I did use the exact form for this calculation here. 5.601 days. Okay, that's correct. Question 4. Question 4. We initially have 100 grams of a radioactive element, and in 1,250 years, there will be 80 grams left. Determine the exponential decay equation for this element. Okay, so if memory serves, it's essentially the same as the above, the exponential growth equation, except with a minus sign in the exponent, which makes sense. So Q equals Q0, the initial condition, times E to the negative KT, I think. But we'll soon see. So, all right, let's figure it out. So in this case, Q is 80. Q0, my initial condition, is 100. K, I don't know. And T is 1,250, the number of years. So solve. Put 80 there, 100 there, E to the minus 1,250k. Divide both sides by 100, we get 0.8 equals e to the minus 1,250k. Natural logarithm of both sides and divide. K is ln 0.8 over negative 1,250, which is a remarkably small number, I guess. (1.785 times 10 to the minus 4, huh? But they want it in the nice, pretty form, right? The exponential decay equation, they want it explicitly written out. So we just say Q equals 100 times E to the negative this number right here, which I guess I could write in full. There's no harm in that. There. It's fine. Okay. How long will it take for half of the element to decay? Okay, now I put that formula in action. So they want half of the element to decay. So instead of 100 grams, like at the beginning, there would now be 50 grams, and that would be the end. Okay, so 50 equals 100 e to the this tiny little number right here to the t. So a half is that. So we end up taking natural logarithms. And we've got to divide through. That's t. So let's see what it is. So I'm just going to type in my calculator ln over half divided by the negative of the answer that you just gave me. And the answer is this, 3,882.85 years. That's the half-life of this radioactive element. And wait, did I call that B? That shouldn't be B, that's part 2. That's not right. There. Okay, part 3 is how long until there's only 1 gram left? Okay, the goal condition is 1. The initial condition is 100. And we have e to the this number here times t. Divide both sides by 100. So we'll get 0.01 on the left and e to the negative this number up here. Natural logarithms of both sides. And then divide through. So t will be the natural logarithm of 0.01 divided by that number there. And I have little doubt that this is going to be a big number. $25,799.27 years. And now we check. Everything must be checked. I did check this, didn't I? Oh, yes, I did. Yeah, I did. That's fine. Okay, good. That's correct. They put it in quote-unquote exact form. I guess I did the approximation. That's fine. And we agree about the number of years for the half-life. And we agree... Wait, no, we don't. Oh, right. Okay, so this is the penalty for not working with exact figures. My calculation is off by 2 years. All right, so lesson learned. In the future, be even more exact. But anyway. Okay, I'm gonna consider that unit to be done. And I'm gonna save it in here. And then I'm gonna begin with what I intended to do today, which is linear systems. Okay. Let me title this. With two variables. For these problems, use the method of substitution to find a solution to the given system, or determine if the system is inconsistent or dependent. So do not use the method of elimination, otherwise you are quite literally doing it wrong. Okay, so how am I going to do this for problem 1? Well, I see x just by itself, so x equals 7y take 11. So wait, how can I indicate that where I got this from? I can say from 1. And if I do it in a bubble, that indicates that it's like the first equation. Yeah. And then I'm going to pick that up and I'm going to put it in equation 2. It seems fussy and obvious at this stage, but when you get bigger systems, it pays off. So anyway, 7y take 11, I'm going to put that right there. Brackets 7y take 11 plus 2y equals negative 18. And now this is a linear equation in one variable, which is home territory and very simple to do. So 37y, take 55 will be here from expansion. So I'm just going to straight away move that onto the right-hand side. So negative 18 plus 55 is 37, isn't it? So y is equal to 1. You can box it or underline it, whatever is necessary to draw someone's eyes to the answer. And then I put that value into equation 1. So x minus 7 equals negative 11. So x is equal to negative 4. And there's my answer. So we check that that was done correctly. Notice there is not one correct solution path. So someone else's approach might have been a little bit different. And that's totally fine. Okay, but we arrived at the same place, and that's good. Problem 2. Okay, now what? How am I going to do substitution here? There doesn't seem to be a simple way to do this. So, but I can clearly see that there's a 2y there and an 8y there. So I'm just going to say, here's what I'm going to do to equation 2. I'm going to rearrange it so I have 2y equal to 4x plus 3. And then I'm going to multiply that by 4. So 8y equals 16x plus 12. And now I have an expression for 8y. So I'm going to put that into equation 1. So 7x minus, open brackets, 16x plus 12, close brackets, equals negative 12. And solve. Here you have a minus sign in front of a pair of brackets. So this move is called distributing the negative, or distributing the negative sign, just there like that. 7x minus 16 is minus 9x. Wait, is that right? Yes. Minus 12 there and minus 12 there. So add 12 to both sides. And we get 0. So this means x is 0. And now that we found out that x is 0, we can pick that up and put it into either equation 1 or equation 2. I'm going to put that into equation 2. Into 2. So 2y equals 3. And therefore, wait, I don't like it in that position right there. I want to put it further over. And I want to say that y equals 3 over 2. And that's my solution. And we check. And that's correct. And that's Good. Problem 3. What now? Well, really, I really don't think there's any way around it other than multiplying the first one by some amount and the second one by some amount, which is really the method of elimination in disguise, isn't it? But whatever. Okay, so I'm going to indicate that by saying 4 bubble 1. That's me multiplying the first equation by 4. And then 3 bubble 2. So I'm going to multiply this second equation by 3. So I get negative 12x minus 36y equals 24. But then what do we observe? Instead of just blindly going forward, what do we observe? That the second equation is the negative of the first equation. So if I were to multiply the second equation by negative 1, they would end up being identical. So let's see. I think the word that he uses is dependent. I was always taught the word was underdetermined. What it really means is that this is a line and this is another line that lies on top of it. So I would personally say the system is underdetermined. And in case there's a dispute about which word to use, just say the reason. As equation 1 is equal to equation 2. They're the same equation. So you can't solve it, or it has infinitely many solutions, whichever way you like to think about it. And yeah, so he uses the word dependent. Infinite solutions. It's like if I say x plus y equals 10. There's an infinite amount of combinations that equal 10. If you include negative numbers and decimal numbers, yeah? Okay, now we get to use the method of elimination. The method of elimination. Problem 4. So what am I going to do? I'm going to eliminate x, and I will say that. It just tells somebody what you're doing. So I'm going to multiply the first equation by 2. Like that. And then I'm going to add that to the second equation. So negative 10y plus 2y equals negative 8y. 16 plus 0 equals 16. So we find out that y is equal to -2. And now I just can put it into whichever equation I like. And I'm going to choose the first equation. So into 1. 6x minus 5 times -2 is equal to 8. So 6x plus 10 equals 8. So 6x equals minus 2. So x equals minus a third. And that's my solution. And we check. Everything must be checked. And that's correct, and that's good. Problem 5. I will eliminate x again. So I'm going to multiply the first equation by 5. So I get negative 10x plus 50y equals 10. And the second equation by 2. Whoops. There. So 10x, take 50y equals 6. But it looks like we're sort of in trouble here a little bit, right? These it doesn't feel like quite right that this could be true, does it? Indeed, if I multiply now the second equation by -1, which I'm always permitted to do, you can multiply an equation by a non-zero number and it will stay the same. So if I multiply the second equation by -1, that turns into a minus, that turns into a plus, and that turns into a minus. And I'll stick the minus sign right there. And, what is this actually telling us? This is telling us that negative 10x plus 50y is equal to 10 and -6 at the exact same time, which is impossible. This is an inconsistent system. Whoops. Graphically and visually, what does this mean? Remember that this corresponds to a line on the xy plane, and so does this. And when you solve a system of equations, you are looking for where those two lines cross. So what does it visually and graphically mean when I have an inconsistent system? It means that the two lines don't cross. They are parallel to each other. That's what it means. So that's my answer to that. And we check. Everything must be checked. Good, no solution. That's right. Oh, yeah. Just in case someone was raised with different terminology and different words to you, it's always just a courtesy just to, quickly say, oh, I mean this, in plain words, whatever. All right, so problem 6. It's getting a bit unoriginal that I would eliminate x again. So I'm going to eliminate y just for variety's sake. So I'll multiply the first equation by 2 and the second one by 3. So 2 times equation 1, this little bubble here means equation 1, gives me 4x plus 6y equals 40. 3 times equation 2 gives me 21x plus 6y equals 3 times 53, 159. But now what? Do the second equation, take away the first equation. It's a little bit relaxed how you symbolize that. So you can just write bubble 2, take bubble 1. And everybody understands that you mean this minus this. 21x minus 4x is 17x. 6y minus 6y is 0. And so y is eliminated. And 159 minus 40 is 119. So x is 7. And now you can put that into whatever equation you like. And I will put it into equation 1. So I write into 1. So 2 times 7 plus 3y equals 20. So 14 add 3y equals 20. So 3y equals 6. So y equals 2. And that's my answer. And we check. Okay, they did the same thing I did. They tried for for variable y, and that's good. Save it. And try the next thing. So who's next? Linear systems with 3 variables. Okay. Find the solution to each of the following systems of equations. All right, so these are always quite a bit of work, but no problem at all. No way. Oh, no wonder it's so dark. There's rain. Okay, so I will concentrate on eliminating variable x. So how will I do that? 3 times equation 1. What's that? Oh my goodness me. Okay, so 114. 2 times equation 2. What? That's not right. 4y plus 8z equals 34. And I will leave equation 3 alone. And now what? Now I'm going to do equation 1 take away equation 2 and equation 2 plus equation 3. Okay, so the first equation now minus the second equation. So 15y minus 4y is 19y. 6z minus 8z is minus 2z. And minus 114 minus 34 is minus 148. And now equation 2 plus equation 3. So minus 4y plus y is minus 3y. 8z minus 7z is plus a single z. And 34 plus negative 12 is 22. What did that achieve? Now we have 2 equations in 2 variables, which is exactly what we know how to solve. Oh man, it is really, really hammering it down out there. So, okay, so I'm going to relabel these A and B just for convenience. And what am I going to do? I'm going to eliminate Z. So I'll tell you what 2b is. It is negative 6y plus 2z equals 44. And then I will add A and B together. So 19y minus 6y is 13y. And negative 2z plus 2z, well, that's 0, like by design, by intention. And negative 148 plus 44 is negative 142. No, wait, what am I talking about? It's negative 102. So I just factorized this morning, actually. 102 is 2 times 3 times 17. No, it's not. What? It doesn't go into it? Oh no, that indicates that I made an error. That would be 4. And 104 is 2 cubed times 13. All right, so y is negative 8. Right, okay, now what? Now use this and put it into B. Wait, which B? That one or that one? Well, they're exactly the same equation, so whichever one is more convenient. So what is this saying? This is saying -3 times -8 plus z, because I'm using this one up here, is equal to 22. So that means z is equal to -2, because that's 24. I take it away and I get -2. And now you can do whatever you want. I will pick up these two I will pick up these two values of y and z, and I will put them into the very first equation. Into 1, so that I can find out what x actually is. So 6x plus 15 times -8 plus 6 times -2 is equal to -114. 15 times -8, well, that would be -120. This makes it -132. And then you must add that on to -114. So what's 132 minus 114? 18, right? So x is 3. So that's my answer. And that's all correct, and that's good. Problem 2. We'll try problem 2. Now we have an equation which does not mention y at all. So the best thing to do is to eliminate y from the other two equations, from one of those other two equations. So then you get another one that only mentions x and z. So here's how I'm going to eliminate y from equations 2 and 3 somehow. I'm going to multiply equation 2 by 6 and equation 3 by 4. And then equation 3, multiply that by 4. So 16x plus 24y plus 20z equals minus 24. And now add them together. So we get, what's 42 at 16? That's 58 to be correct. Negative 6z plus 20z, that would be 14z. And negative 90 plus negative 24 is negative 114. So they're all even. So I'm going to just divide everything by 2, just for simplicity's sake. And now what? Now I shall also just write equation 1 underneath. And this is good because we have 2 equations in 2 variables, which we know what to do. We know what to do. So let's eliminate, well, who do we eliminate? All the numbers are really bad. I'm going to eliminate Z. I'm going to eliminate Z. All right. So I'll relabel that A and that B for convenience. And to eliminate Z, I'm going to do equation A times 9 and equation B times 7. So here we go. 9A. What's 9 times 29? 263, no? $63 there. Wait, did I do that right? Why do I feel like I'm just messing up arithmetic today? Really, I am. That's strange, actually. I was fine this morning. Okay, so 9 times 29 is 261. That's better. 9 times 57, negative 513 is going to be here. And now 7 times equation B. So 21x takes 63z equals 231. And now add them together. So we are going to get 282x. And you have to add these together. Oh no. Oh, please be something rational. Yes. Okay, so just add them together. 382. Is it 382? Or am I messing up again? Well, I think it's 282, isn't it? Yeah, it's 282. Negative 282. All right, so that's fine. So x is negative 1. Now that we know that fact, I'm going to put that into this nice version of equation B right here. So 3 times negative 1, so negative 3. Take away 9z or z, whatever you want to call it. And negative 9z is equal to 36. So z is equal to negative 4. And now that we have that fact, we are going to put it into equation 2, the original equation 2, actually. No, we'll put it into equation 3. So I'm going to say 4 times negative 1 plus 6y, because I don't know what y is right now, plus 5 times negative 4 equals negative 6. So what does that mean? That means negative 4 and negative 20. So we get negative 24 and add that on. So we get 6y is equal to 18. So y is equal to 3. And that's my solution. And that's correct, and that's good. Right, so I will save it. And see who is next. Who is next? Augmented matrices. All right, so I'm going to have a quick bathroom break. Okay, so augmented matrices. Problem 1. For the following augmented matrix, perform the indicated ERO, elementary row operations. This says multiply row 1 by 8. So I will have 32, negative 8, 24, and 40. And the rest of it will stay the same. So 0, 2, 5, 9, negative 6, 1, negative 3, and 10. Row 2 swaps with row 3. So row 1 stays where it is. And row 2 is now row 3. So negative 6, 1, negative 3, and 10. 0, 2, 5, and 9. And this, what is this saying? Replace row 2 with row 2 plus 3 times the sum plus 3 times row 1. So in my mind, I think of this as rows 1 and 3 remain exactly the same. They stay exactly the same. So if I get this wrong, at least I got that right. And now for row 2, I need to add on 3 times row, I need to add on 3 times row 1. So this 0 right here, I must add on 12. This 2, I must add on negative 3. So I write negative 1. This 5, I must add on 9. So it becomes 14. And this 9, I must add on 15. So it becomes 24. And that's my solution. And we check. Everything must be checked. So the first one is correct. And the second one is correct. And the third, that's also correct. Problem 2. Okay, some more elementary row operations. First, just compute half of row 2. So rows 1 and 3 stay exactly the same. Exactly the same. And row 2, divide each entry by 2. So this will become a 1, this will become negative 4, this will become a 5, and this will become a 2. So 1, negative 4, 5, and 2. Next up, swap row 1 and row 3. Swap row 1 and row 3. So row 2 stays exactly where it is. So up here on row 1, write row 3. So 3, -4, -1, and 2. And down here on row 3, write row 1. So 1, -6, 2, and 0. And part C. Row 1, take away 6 row 3. And that means that row 2 and row 3 will stay exactly where they are. Two, -8, 10, 4, 3, -4, -1, 2. And now, this one right here, you need to take away 6 times 3. So what's 1? Take away 6 times 3. That is -17. This -6, you need to take away 6 times -4. So that's the same thing as plus 24. So that becomes 18. This 2, you need to do 2 take away 6 times -1, which is 2 plus 6, which is 8. And finally, this 0. Do 0 take away 6 times 2, which is -12. And that's my answer. And we check. The first one is correct. The second is correct. And the third is correct. The third one, just some more EROs, elementary row operations. So first, I'm to multiply row 3 by -9. So row 1 and row 2 will stay exactly where they are. But for row 3, I multiply everything by -9. So 0 there, -63 there, 18 there, and -27 right there. Part B. Swap the first and second row, and that means leave the third one alone. So row 2 is now in the first row. So I write 4, 0, 7, -1. And row 1 is now in the second row. So I write 10, -1, -5, and 1. And finally, I have to change row 3. I have to replace row 3 with row 3 take row 1. And that means that rows 1 and 2 stay exactly the same. So 0 minus 10 is minus 10. 7 minus minus 1 is 8. Minus 2 minus minus 5 is minus 2 plus 5, which is 3. 3 minus 1 is 2. And that's my answer. Okay, that's correct. And that's correct. And that's correct. Okay, so that has achieved my goals, but nonetheless, I'm going to look forward. Right. Okay, I'll have a go at this. More on the augmented matrix. I mean, what's the point in learning those skills, right, if they can't be used to solve something, to answer something? So I'm going to try that right now. Okay, problem 1. First, I'll convert it into an augmented matrix. So I just strip off the coefficients. So 1, negative 7, negative 11. 5, 2, and negative 18. Now what? Well, ordinarily, I would try to eliminate x. I would try to eliminate x. I mean, here, to be honest, I would use substitution. But anyway, to eliminate x, multiply the first equation by 5 and then subtract 1 from the other. So I'll write 5 minus 35 minus 55 and leave the second one alone. But then I have to tell someone what I've done. So I'll just write 501. And then ordinarily I would think, oh, okay, I can either subtract the top from the bottom or the bottom from the top. It doesn't matter if I'm eliminating x. So let's see. I would do replace row 2 with row 2 minus row 1. Row 2 minus row 1. So that will turn into a 0. And 2 minus minus 35 is 37. And negative 18 minus minus 55 is 37. And the first row stays the same. But I have to say what I'm doing. I have to say what I'm doing. So row 2 is replaced with row 2 minus row 1. Then I would divide the second row by 37. So I get 0, 1, 1. And I will divide the first row by 5. And finally, I will replace the first row with the first row plus 7 times the second row. Or row 1 to row 1 plus 2 row 2. No, row 1 to row 1 plus 7 row 2. I guess that would be correct to say. And I need to indicate what I'm doing. There, like that. So what does this mean? This means that I've just found out what x and y are. So x is -4 and y is 1. Right? Yeah, so we arrive at the same solution. The thing is, though, I had to write out 6 augmented matrices. There must be a more efficient way to do it, right? So we inspect. Okay, so they sort of do this and this in one step. Okay, that's nice. I get you. I get you. And then that. And then these are combined in one step. And there you go. Okay, not a problem. Let's see if I can do that. Number 2. So, as he said, we need to make the number up in the top left-hand corner a 1. So anyway, 7, -8, -12, -4, 2, 3 is the starting state. So what is the standard sort of way through this? Because if you multiply the first row by a 7th, that is just really, really dumb. I just don't see how that's a productive idea at all. And let's see here. Let's think what's really going on. Both in agreement there. You know what? Just proceed like you usually do. I don't think anybody does this in real life anyway. So add them. right? And we discover that it's an inconsistent system. No, we don't. No, we blimmin' don't. That's totally wrong. You know what? We can achieve our goal right now. We're going to do this. And we're going to indicate that first we swap them. And then I multiplied row 1 by negative a ninth. You get me? So there. And then I'm going to take away 7 lots of row 1 from row 2. So that should be 0 by design. That should be negative 8 by design. That should be negative 12 by design. Right, but you have to indicate what you're doing here. So row 2 is row 2 minus 7 times row 1. Okay, so row 2. No, just do something like this. Negative an eighth of row 2. So, like that. Wait, is that right? Is that right? Well, I think so. We'll soon see. Yes, it's right. I really don't know why anybody would do this for. I suppose some people get so good at it, they can do it in their sleep. And I continue. There must be like some better way. I understand that you don't have to write the X and Y anymore, but it just seems so ridiculous to solve something this way. All right, so I'm going to do 2 things at once. So 4 row 1, so 4 times that, just one thing at a time, yeah. Three times that. Oh, wait. Inconsistent. No, not inconsistent, dependent. That's his term. and we check. Yeah. But it looks like they parameterize it. I don't see the point really. You have, I mean, this is just doesn't really do anything. You could just write that with y and just say pick your value of y and you can get x. There's no need to introduce t. 4. Okay. If this takes up like half a page again, it's established that it's just not a great method. Okay, so like even just writing it down, it just wastes a step. It just wastes a move writing it down. So why don't I just straight away write down the double of row 1? 12, negative 10, 16. To row 1, like that. That's good. And now add row 1 and 2 together. But how do you do that? You do row 2 add row 1. Okay, so I'm going to have that, aren't I? I'll have that. You know, I might protest and say, hey, it seems so inefficient, but if people are doing this, I need to give it a shot at least. So, okay. Hmm. Whatever. 16 over 12 is 4 over 3. And then to row 1, add a sixth of row 2. Nope, totally wrong. Fine. To row 1, add 5/6 of row 2. So I'll get a 1 there, a 0 there, and what's 5/6 of negative 2? That would be negative 10 over 6, which is negative 5 over 3. And add that on to 4 over 3, and I get negative a third. But I have to indicate what I'm doing. Can't just do things randomly. Right? We'll see. Okay, it's correct. 5. All right, so 5 and 6 are samey. So just get better, quicker, more accurate. You know, so I'll write down equation row 1 times 2. 10, negative 50, 6, and a bar. Row 2 times 5. Negative 10, 50, times 5. So there, and the bar. And, but I need to indicate, don't I? I need to always indicate what I've actually done. No, wait, I can just do this. 2 row 2, 2 row 1, 5 row 2. And then what do we observe? We observe this is inconsistent. But what do they say about it? All right, fine. So more or less the same. So no solutions. Problem 6. I'll do that times 7 and that times 2. Be very robotic and mechanical, I guess. 14, 21, 140. 14, 4, 106. But you need to indicate what you've done. So 7 row 1, 2 row 2. Row 2 replace with row 2, take row 1. So 0. No, that would be, no, I don't care. Negatives numbers are fine. So 4 minus 21 is minus 17. 106 minus 140 is minus 34. And there you go. And now, negative a 17th of row 2. And while I'm at it, a 14th of row 1. So 1 there. 21 over 14 is 3 over 2. And that would be 10. Now, replace row 1 with subtract 1.5 times row 2 from row 1. And that's how you get a 0. like that. So we have our solution. Yes, we do. Okay, that's great. And now, the 7th problem. Proceed. Okay, fine. I will write this 3x3 augmented matrix. This is probably going to take pages, no? This is supposedly as well where it comes to shine. So what do I do? All right, I'll try and eliminate 0 from the first column except for 1. Something like that, right? So let's do it. Let's multiply the first row by 3 first. So 6, 15, 6. And wait, major deja vu. So times up by maths is always deja vu. So negative 38 times by 3 is negative 114. Yeah, I'm pretty convinced that he's done this before. Well, then it should be even easier, right? Yes, it should. Okay, and come on, 3 row 1, 2 row 2. That's what I just did. Now, to row 3, I shall add row 2. So I will get 0 minus 3 come on, minus 7 plus 8, 1. And what is minus 12 plus 34? Well, 26, isn't it? So what did I just do? I just did row 3 to row 3 plus row 2. And for row 2, I shall replace row 2 with row 2 minus row 1. So I will get a 0. And negative 4 minus 15 is negative 19. Yes, I'm almost 100% sure that he did this now. Okay, so 8 minus 6 is 2. 34 minus 114 is 34 plus 114, which is 148. And say what you did. Row 2 is row 2 minus row 1. Now what? Now eliminate this, turn this into a 0 here, something like that. All right. I'll do that. So I'll multiply it by 3 and that one by 19. This by 3. What's 148 times 3? 444. What? It is? Oh, wow. It can't be. No, it really is. All right. And this one here by 19. So what's 19 times 26? Well, it would be 520 take away 26, which is 494. Okay. Okay. I'm staying with it. But what did I do? I did row 2. No, I didn't. I did 3 times row 2 and 19 times row 3. That's what I did. Okay. 2 EROs at once. And now for row 3, I shall subtract row 2. That's what I'm going to do. So 0, and that should be 0 as well. Minus 57, minus 57. And so 19 minus 6. 13. 494 minus 444. 50. Oh no. A non-multiple of 13. Definitely did it wrong. Well, messy fraction, you know you have gone down the wrong path. Yep, I saw integers. So I made a mistake somewhere. So find the mistake. In a sort of like an unsung skill, isn't it? Finding an error in your own work. Okay, so I copied down the matrix correct. Then, did I multiply the first row by 3 correctly? Let's think. Yes. And the second row by 2 correctly? Let's think. Yes, I think so. Okay. To row 3, did you add row 2 correctly? What's negative 4 plus 1? Found it. Found the error. That should be a 22. And let's see what the knock-on effects of this are. So if that's the 22 there for row 3, and I did 19 times 20 times row 3, then it should be 19 times 22, which is 418, I think. Yes, 418. Okay, so we begin again And what was it we were doing here in the first place anyhow? Well, I was doing that to take away that, wasn't I? So 418 minus 444 is minus 26. Right. Got it. Okay. But I need to say what I did. I did row 3 and replaced it with row 3. But I took away row 2. Now what? I have to do this. There. There's no way I could do this all the time. It's just too much. I can so see why they delegate this particular thing to computers. Okay, so we've established what Z is. And now what? Now, you add that on to, you replace row 2. Replace row 2 with row 2 minus 6 times row 3. All right, so I will have a 0 there by design. 6 minus 6 times 1, and then 444 minus 6 times negative 2. So 444 plus 12, so 456. But does that work? Yes, it does, because it's negative 8, isn't it? I mean, this is just ridiculous. Continue. I mean, look how stupid it is. It's just so repetitive, but so am I. So 8. Oh no. Oh no, wait, no, that's fine. That's absolutely fine. False alarm. Excuse me, but while I'm here, would you mind if I divided that first row right there by 6? No, not at all. Go ahead. Okay. Let's do it. So that will be a 1. That will be a 2.5, which is 5 over 2. That'll be a 1. And divide that by 6. Well, that's negative 19, isn't it? So indicate what you did. 1/6 of row 1. And now what? All right, so those have to be eliminated, don't they? So I guess you would do row 1, take away row 3 first. No, you could just do row 1, take away row 1, replaced with row 1, take away row 2, take away. No, wait. No, that's wrong. Oh boy. Okay. Take away row 3 and take away 5/2 times row 2. Yeah. So that'd be a 0 there and a 0 there by intention. These are already solved. And what is negative 19 minus minus 2? Well, that would be negative 19 plus 2, which is negative 17. Okay, got it. Now, what is negative 17 minus 5/2 times negative 8? Well, that would be negative 17 plus 40/2 plus 20, so 3. And I see integers, and I'm happy about that. So it's finished. It's done. I hope I never have to do this again. Okay, great. Okay, that's done. Okay, maybe the 8th problem can come back another day, because I'm not doing that all over again. No blimmin' way. Way too long. I mean, what's the lesson? To be grateful for computers. All right, so this is what I was looking forward to. Nonlinear systems. Non-linear. Okay. I'm gonna have some water before I do this, because this is gonna be fun. Oh boy. A quadratic and a linear. First, I'm going to set them equal to each other. So x squared add 6x take 8 equals 4x add 7. Then I'll turn it into an ordinary quadratic. So plus 2x, take 7 from that, minus 15 equals 0. And then I will turn it into x add 5 times x minus 3 equals 0. And then x is equal to negative 5 or 3. But then what about y? Just pick them up and put them in the linear. So 4 times negative 5 plus 7 is negative 20 plus 7, which is negative 13. And 4 times 3 plus 7 is 19. So in summary, it's negative 5 comma negative 13 and 3 comma 19. And we check. Oh no, wait, what is this? Oh good, that's for the second problem, but the formatting had a bug, I guess. Great. I'm happy about that. Problem 2. So I have an expression in terms of for y, and I'm going to replace that y right there with it. So x squared over 4 plus 1 take 3x all squared equals 1. Multiply everything by 4 to get rid of that. What was that? So multiply everything by 4 to get rid of that fraction. And expand it out. Okay, so that would be negative 9x squared. So that becomes negative 36x squared. Negative 6x, so that becomes negative 24x. And plus 1. And solve. Solve, solve, solve. Oh, take away 4 from both sides, no. Man. Divide both sides by... wait. No, they're coprime. They are coprime. Sure. So turn it into its positive version just to get rid of these annoying negatives. Like that. And so x is 0 or negative 24 over 35. And now that you have established that, pick those numbers up and put them in the linear. So y would be 1 when x is 0. And what's negative 3 times negative 24 over 5? Well, that would be 72 over 35, wouldn't it? And 1 plus 72 over 35. Well, 72 over 35 is 2 and 2 35ths. And then you have to add 1 to that. So you get 3 and 2 35ths. So there you go. 0, 1. And this business here. There. And we check. And we check. And oh no. Fine. Try again. Well, maybe he made the mistake. But what's more likely? More likely is my error. So try. We get no, that's going to be positive, don't you see? Oh my goodness me. So that'll turn into 37. We see the cascading effect of an error. That will be a 7, and that will be a negative sign there. And 0 remains totally fine, doesn't it? No. No, yes, it does. It does. Okay, so in reality, this is 24 over 37. That's the correct solution. Fixing, fix. 24 over 37. And then pick it up and solve it. So what's negative 3 times 24 over 37? That would be negative 72 over 37. So 1 minus 72 over 37. Not right now. Is what? Hello? Oh, negative 45 over 37. How about that? Okay, so 24 over 37, negative 45 over 37, and check. Goodness me, what's... Oh, what a blunder. That should be a 3. All right. Fine. Okay, good. All right, so problem 3. A hyperbola and a circle. So these can have 4 intersection points, right? Whoops. Problem 3, not problem 4 itself. So what am I going to do? What am I going to do? Well, I guess I just have to turn x into 4 over y and just pick it up and put it in there. Okay, so we have 4 over y, which is being squared, and then divided by 4. And then we have to add y squared over 25 equals 1 to that. First, I'm going to get rid of these fractions. So I'm going to multiply everything by 100. So that'll result in this, and this, and this. Next, 4 over y squared is 16 over y squared, isn't it? So what's 16 times 25? Oh my goodness me. 400. 400, right? Okay, so what? Well, that's 400 over y squared now, plus 4y squared equals 100. Okay, so times everything by y squared. So we're going to have 6. What is that? We're going to have 4y to the 4 minus 100y squared plus 400 equals 0. All right, so I'm happy about that. And I'm going to divide everything by 4 just for convenience, like that. Now, this is in quadratic form. So let z equal y squared. Then we rewrite this as z squared minus 25z plus 100 equals 0. And you can factorize this into z minus 20 and z minus 5. Times to make the and, add to make the middle. So what does that mean? That means that z is equal to 5 or 20. But who is the z? Z is something I made up. So now I have to turn it back in to y, the original variables. Plus or minus root 5, or plus or minus root 20, which is 2 root 5. So there are the 4 possible y values. And now you must obtain the 4 possible x values. So what I'm going to do is I'm going to put some brackets here like this. And in the y coordinate positions, I'm going to put positive root 5, negative root 5, positive 2 root 5, and negative 2 root 5. And then I'm going to work out what x should be. So for the first one, we have that x should be 4 divided by root 5. 4 over root 5. But I'm obliged to rationalize that denominator. I don't know why. It seems perfectly okay to me, but they don't like it. So top and bottom multiply by root 5, and I get 4 root 5 over 5. Next. Exactly the same. Oh, but this time it'll just be the negative, right? Because it's 4 divided by negative root 5, which is negative 4 root 5 over 5. And now 4 over 2 root 5, which I guess is 2 over root 5. And when you multiply it out, you get 2 root 5 over 5. And if I think about it, this is essentially the same, but negative. So I hope that I did that right. But wait, how can I have a feeling that I did it right? How can I have a feeling that I did it right? This is a hyperbola which is symmetric about the origin. And this is a circle which is centered upon the origin. And therefore, I expect the solutions to have this symmetry to them. But now we check. That's great. Excuse me, Paul, you didn't rationalize your denominator as you have been telling me to do, but that's totally fine. It's totally fine. Okay, last one. Last one. I have a parabola and a circle. So this and this. Now, if you think about it, I could have a circle that does this and a parabola that sort of like does this. Or this, touching it just once. Or this, or this, or this. So 0, 1, 2, 3, and 4 solutions are possible. That's how many are possible. So let's see. So, well, how about I get a feel for it? Okay, well, this is a circle centered upon the... No, it's not a circle. That's totally flipping wrong. And look, I made a mistake when I said it earlier. This is an ellipse. Don't you recognize an ellipse when you see one? So is that, and so is that. Man, I am making mistakes, but I'm also finding them. Which, you know, means, which is a good thing. But anyway, it's an ellipse. So it's centered upon the origin. Okay, 2 foci there and there. And this is an upside down parabola, but a little bit above the origin. So I don't know. I'm just getting a feel for how it looks. Anyway, we're told that y is equal to 1 minus 2x squared, so I'm going to pick that up and put it exactly where y is. No, I'm not. First things first, I'm going to multiply everything by 9. 9x squared minus y. 9x squared minus y squared equals 9. And now pick up y and put it right there. Tell people what you're doing though. Don't just write stuff down. No one's a mind reader. Okay, so 9x squared minus, open brackets, 1 minus 2x squared. That should be squared, by the way. All right, so equals 9. Now, to not make mistakes, just square what's in the brackets. Just square what's in the brackets. So we get 4x to the 4 minus 4x squared plus 1. Isn't that right? Equals 9. And now carefully take care of this. So minus 4x to the 4. And that will be plus 4x squared. So 9x squared plus 4x squared is 13x squared. And then we have a minus 1 here. And then bring that 9 over, and we get it to be a minus 8. This is in quadratic form, but I'm just going to turn it positive. You know. Oh, and while I'm at it, just let z equal x squared, you know. Always a dangerous thing, doing 2 moves at the same time, but you have to try. So, can this even be factored? Or am I chasing something which doesn't exist? So b squared minus 4ac, the discriminant. And let's see. The square of negative 13 is 169. And then you have to take away 4 times 4 times 8, which is 169. Take away 16 times 8, is it not? So take away 128, which is 41. So it can't be factored, but I have to see if this is true. Did he really set this as a last one? So I'll glance, and if I see integers, I know I've gone down the wrong path. What the hell? Oh no, something like that. Something like that. Okay. I just think that this is totally wrong. 41. It's just so arbitrary. Like, what do you do? No. Stop. That's the discriminant. True, it's 41, so it's not going to have, you know, super tidy solutions, but the solution could be like root 3, you know? It's just not going to be a nice integer solution. But anyway, all right, so here we go. How to solve this now? Solve by completing the square. Oh my goodness me. Continue. 4. You know what? I'm going to divide everything through by 4. Might not be the best thing to do, but I really can't be dealing with this, you know, pesky 4 business right now. There. and then complete that square. All right, so I'm going to have this. But then when I square this out, I've created 169 over 64 out of absolutely nowhere. So we have to subtract it away to balance the books. And now what? What is 2 minus 169 over 64? Well, that would be, that's where it comes from, by the way. That would be 2 and 41 over 4. So what? 41 over 4 on the right? No, 41 over 64 on the right. I know I've gone wrong. I just know I have. There's no way. There's no freaking way that that's right. Okay. Where did I go wrong? Okay. Did I times everything by 9 correctly? Yes. Did I pick up y and put it in there correctly? Yes, I did. What did I do wrong? What did I do wrong? That should be 10. That should be 10. See? Now, fix this as well. All right, so 4 times 4 times 10 is 160. So it can be factored after all. And the world is beautiful again. Thank goodness. I mean, really. So we'll try it out. Okay. So how do you make 13 from that? How? Am I even struggling with this right now? Goodness me. No. Because, no. Because, no. This way. This way. Over here. Over here. All right. What's okay? So -5 and -2, right? That's right. So we see that z is 2 or 5 over 4. Now that that has been established, we say that x is the square root of these. All right, okay, so fine. So we have that. So I don't know if there's 4 solutions. I don't know, but we're going to see. So x squared was used to stand for z, was it not? It was. And therefore x is root 2 or minus root 2. The square root of 5 over 4, which is root 5 over 2 or minus root 5 over 2. And now you must find the corresponding y coordinates. Okay. One last push here. I can't do it in my head right now, so I need to actually write it out. 1 minus, okay, that's going to be a 2. So 1 minus 4 is a minus 3. There we go. In here, it will be the same. And then here, square root 5 over 2, why don't you? Oh, it's 5 over 4. Of course it is. 5 over 4. And then times that by 2. So we get negative 5 over 2. And 1 minus 5 over 2. 1 minus 5 over 2 is minus 3 over 2. Don't you know? Same thing here. It's time to see if any of that is correct, though. Or is it just nonsense? Okay, I can't see it when you do this. And that's correct, and that's good. Okay. Non-linear systems. And now the algebra section is complete. It's finished. So next time I'll look at calculus 1. Next time. Be well, be well.